Morning, class.
Good morning.
Good morning.
Good morning.
All right. Guess first things first, let's go over the exam from last time. Okay, so number one, we needed to solve for x as always. On this one, we have to get rid of the 3 and the 4 off of the x. So since we're dividing by 4, we're dividing x by 4, we need to multiply both sides by 4. Make sure whatever you do to one side, you have to do it to the other as well. And since we're multiplying x by 3, we need to divide both sides by 3. So the 3 over 3 is 1, 4 over 4 is 1. We have x here is equal to 6 times 4 is 24 over 3. And 24 divided by 3 is 8. All right, about half of y'all are getting these problems, and about half of y'all have a lot of work to do. So when we do the quizzes in the breakout rooms, be sure to help one another here. A lot of people are still making the same mistake on problems like this. If you flip one side, you have to flip the other side. Just think about this. 2 is equal to 2, right? 2 over 1 is equal to 2 over 1. If I just flip one side and not the other, I get 1/2 is equal to 2. And that's not true, right? So think about what you're doing whenever you're doing these things, all right? If you flip one side, you have to flip the other. So you put the 4x on top and the 3 on the bottom. We have to flip the 6. That's going to give us a 1 over 6. 6 is the same as 6 over 1, right? So from here, we have a problem that looks just like the one above. It's going to be the same trick. We got to get rid of the 3. And we got to get rid of this 4. So we need to divide by 4. 3's go away, 4's go away. X is 3 times 1 is 3, 6 times 4 is 24. We can reduce this because 24 is 3 times 8. 3's go away and we're left with 1/8. All right, any questions about this?
No.
All right. So let's go ahead and do a quick quiz then. This would be quiz number 3. Do another solve for x. And 2 over 3x equals 5. Number 2. What is 17% of 200? I'm going to put y'all in the breakout rooms. We'll take, how long do y'all want to work on this one together?
Probably like 15 minutes
15 minutes, all right.
or whatever. I don't know.
That works. So it's 10:35, so 10:50. We'll get together and work this thing through. Here we go.
Excuse me, sir. How can I join the breakout room again? I had to take a picture of the questions.
Oh, no problem. Let's see, I got you here.
Thank you.
Room two.
I think I need to get into a breakout room.
Okay, I got you. Let's see. Okay, I see. Let's see. There we go. All right, class. Let's check out this quiz here. Remember, y'all have until midnight tonight to submit your quizzes. All right, you don't have to submit them during the breakout room session unless you want to. Also, we work the quizzes here in class, and then I post the notes in Canvas. So you have access to the solutions to the quizzes. So my last quiz, about half of y'all messed up at least one of the problems. So you should be getting all the quizzes perfectly done, since one, we do them in class. And if you miss class, you could still look at the solutions because they're uploaded. And exams, remember, you have access to tutoring as well. There's a link in the syllabus to tutoring, and they can help you work these problems. In addition to that, you remember you have those apps on your phone, the photo math. Did we talk about this last time?
No.
Yeah, there's you can download apps that'll do math for you. So you can at least, I mean, you have to show your work, but like these apps, I think you just point the phone at a math equation and it solves it.
Yeah, it also gives you like the whole like explanation on kind of how you get to the answer.
Oh, there you go. So yeah, utilize all these resources: photo math, fast math,
And then there's Mathway as well.
Mathway. Pathway. I like Wolfram Alpha. It's a bit more powerful than you probably need, but so yeah, use these apps on your phone. Again, show your work. You know, use these as learning tools, not just a thing to get the answer. You know, but part of learning is knowing if you got your answer right or not.
What if we actually use our phone calculator, like for the percentage ones?
So what's that?
What if we actually use like our calculator on our phone?
Oh yeah, that's fine. That's what I
percent
expect you to do. And some of y'all, I guess, don't know there is a Canvas app. All right, so the Canvas that you go through, you can download the app, the Canvas student app. And I'm assuming you could use that to take pictures of your work and submit your answers really easily. See, some of y'all are trying to use like your webcam on your computer, and the resolution isn't all that great sometimes. So I recommend using that Canvas app. All right, so number one we need to do here is, since the variable's on the bottom, what do we do? Somebody tell me.
We're going to flip them
Yeah. We have to
and then divide voice from both sides.
Yeah, make sure you flip both sides. Yeah, that's critical. Okay, now what do we do? Anybody tell me what we do next to get that X all by itself?
Divide both sides by the same.
All right,
Three.
what are we going to divide by?
The same to 3, 2,
We got to divide both sides by 3, right?
and 2. Yeah.
We got to multiply both sides by 2. Okay, so the 2's go away, the 3's go away. So we're left with X. Here's our X equals 2 times 1, 5 times 3, or 2 over 15. Any questions about that one?
I have 15 over 2. Is that still,
15 over 2.
because I guess I didn't flip the other one.
That looks possible. Let's see. If you didn't flip this side, you wouldn't have 1/5. You'd have 5 over 1, and you would have 10 over 3. So let's see. What are you doing wrong here? Did you flip both sides?
Yes, I flipped both sides.
So you
Hold on.
you got
So-
the step, right?
Right. So let me see what I did wrong. I'm going to look at your problem really quick.
Hold on a second. You're okay, puppy dog.
I ended up getting 15 too also, but the thing that I did wrong was I only multiplied the x, and that got me 2x instead.
Okay, yeah, if you're gonna multiply one side of the equation, you have to multiply the other, right? We multiplied both sides by 2/3. I saw some of y'all doing that. You just multiply one side, not the other. Yeah, you can't do that, right? If you have 2 equals 2, I can't just be like, I'm just gonna multiply this side by 3/2, right? Because then that's not equal, right? You have to maintain that equality. So let's go through this. We multiplied both sides by 2/3. So the 2 and the 2, 2 over 2 is 1. 3 over 3 is 1. So over here, we got 1 times 2 is 2. 5 times 3 is 15. Yeah, when you flip, you have to flip both sides. If you multiply one side by something, you have to multiply the other side by the same amount to maintain equality.
Is this an equation that you'll always have to flip? Because I multiplied both sides by 3x and still got the same answer.
Yeah, you can do it that way as well.
Okay.
Let's check that out. Check out another. See if I multiply 3x, 3x, right? The 3 over 3x is just 1, right? So now I'm left with 2 equals 5 times 3 is 15x. And then I divide both sides by 15. So I have x equals 2 over 15. So yeah, you can do it that way as well. All right, y'all ready for number 2?
Yes.
All right, so we want to get 17% of 200. So we take 200, we multiply it by 0.17. And totally welcome to use your calculator anytime you want. 200 times 0.17 is 34. This one you could do in your head. What would 17% of 100 be?
$17.
That's right. So 17% of 200 is just twice that. So twice 17 is 34. Any questions about that one?
No.
No, sir.
All right. So we left off on number 15 last time. So let's look at 16 here. All right, Thomas is selling his Honda CRV on consignment by leaving it with a dealer. The dealer will get 25% of the selling price. What must the selling price be in order for Thomas's share to be $14.75? Okay, so that means Thomas is getting 75%, right? The dealer gets 25%. So there's going to be some price, right? And we need 75% of it to be $14.75. Does that setup make sense for y'all? We're taking 75% of some quantity and getting $14.75 because that's what they're looking for. Thomas wants to get at least $14.75, but he's only getting 75% of the total. So to get x by itself here, you need to divide both sides by 0.75. And let's see. 1475 divided by 0.75 is 1966.67. So let's we could check our work here. If we charge this much, right, and we take 75% of that, we should be getting 1475, right? So multiply that by 0.75. Yeah. So it checks out. You always want to check your work. Problems like this in this quiz up here. Let's how would we check our work here? Okay. Here's the answer that we got, right? So if that's our answer, how do we check our work? You plug this into X here and make sure that equality holds. So if we plug that in, 2/3 times 2/15. You plug it into this side, the left-hand side. Now this had better equal to 5, right? Because that's what we're when we solve for X, we're finding the number that makes this thing equal. So let's simplify this and make sure that we get 5. So we got a 2 over, let's see, if we multiply these, we have a 3 times 2/15. 3 times 2, 15 is 3 times 5. 3's go away. So dividing by a fraction is the same as multiplying by its reciprocal. So instead of dividing by 2/5, we'll multiply by 5/2. So that's how you check your work. You take the answer you get and you plug it in for X and make sure that it holds up. So let's look at like this exam up here. When we get an 8, if we want to check and make sure that that's the right answer, if we look at the original equation, it was 3/4 X equals 6, right? That's the original equation. Plug in 8 for the X. We have 3/4 times 8. And that better equal to 6, right? To show that the equation is equal. So 8 times 3 is 24/4. It's 6. Right? So when you work problems like this, don't just get a number and then stop. Take that number and plug it back into the equation and make sure that it's the correct answer. Let's see. Number 17. 2004, Javier bought a new television set for $2,500. Okay. In 2012, he purchased a similar model for $950. What was the percent decrease from 2004 to 2012? Round to the nearest 1/10 of a percent. Well, let's see. Percent decrease. Well, it went from what? Went from 2,500 to 950. So what kind of a price drop is that? $2,500 minus 950. So it dropped $1,550. Okay, so that's how much the price difference is. But they want to know what the percent decrease is. So it went from 2,500 to 1,550. So if we put that in a ratio here, remember this is the part, this is the whole. All right, dollar signs go away. We have 1,550 divided by 2,500 is 0.62, which is 62%. All right, it makes sense. It went from 2,500 to 950. That's less than half the price, right?
Yes.
At 1,250, that would be half the 2,500. That would be a 50% decrease, right? So since it's less than 1,250, you'd expect a percent decrease that's bigger than 50%. Right, and we could check our answer, right? If we have 2,500 and we take 62% of it, 2,500 times 0.62, we get 1,550, which was the price difference, right? Am I doing that right? Yeah, that's the price difference there. Any questions?
No,
No, sir.
Number 18. All right, the price of gas increased from 325 to 405. What was the percent change to the nearest percent? Let's see, well, how much did it change by? Let's see. Let's use, thinking here they gave us. They gave us a formula, so let's go ahead and use our formula. Let's see, give it that to us. So just using the formula, we got new price minus old price. So we have 405. Wait, that's the old price, right? New price is 325. And old price is 405. And they say to take that, multiply it by 100. So this is just mindlessly using the equation, right? It's the same thing we did up here in this one. We just subtracted first and then divided that difference. So that's what we're doing here. We're finding out the difference and then dividing it by the whole. And then multiplying it by 100 to get it as a percentage. So let's see, 325 minus 405.
80 cents.
Negative 0.8, right? And we need to divide that by 4.05. Oh, we gotta remember times 100. So we get negative 0.1975 times 100, which is a negative 19 point, would be 75, right? So that 5 is going to round the 7 up to an 8. That's our percent. Negative 19.8%. So why are we getting negative here? Old is, oh, I got the old and the new mixed up, didn't I? It increased from 325 to 405. Okay, so I got the old and the new wrong. So let's try this again. Wrong. The new one is 405. The old one is 325. And then multiply by 100. Okay, so 405 minus 325. 405 minus 325. It's still 0.8, but it's positive, not negative, right? And then on the bottom, instead of dividing by the 405, we're dividing by 325. Because the old price is 325. So 0.8 divided by 325 is 0.2461 times 100 gives us 24.61%. So last time I had these switched, right? So we ended up with a negative 0.8, but also the number on the bottom I had wrong because I had the olds and the news switched. So you take the difference between the two and then put it over the old price. It's like what we did up here in this problem where we went from 2,500 to 950. We took the difference and that was 1,550, and then we divided it by the old price. And then we took that and multiplied it by 100 to get the 62%. So it's just the difference divided by the old price, and that gives you your percentage. If it's positive, it's increase. If it's negative, it's a decrease. Any questions about this one?
No, sir.
Okay. Kind of distracted. I got a wounded dog here. I guess somebody's big mean dog got out and attacked my little poor dog. He'll be okay. He just has some bad cuts and his leg hurts. Sold the CRV. Dealt with the gas. Mixtures. All right. Last time I taught this, I looked at this and I was like, what the hell? It was so confusing and I had to do a lot of research. And basically what this book is missing is the formula. See, some of these start off pretty easy, but then they get complicated real quick. And there's one specific formula that we'll need in order to deal with problems like this, these mixtures. Let's look at this problem here. Mixing 1 gallon of 100% apple juice with 1 gallon of water. How much total liquid results and what percent is juice? Well, that one's kind of easy. If you have a gallon of juice and a gallon of water, you end up with 2 gallons of liquid. What percent is juice? Well, it's half water and half juice, right? So it's 50% juice. Now, what if you start changing these percentages? You know, what in the gallons? What if it's a half a gallon of 75% juice with 2 gallons of 25% juice? You see what I mean? It's easy to add up the gallons, but what is your resulting concentration? So, yeah, the first question you can do in your head, let's look at this second one here. What if you mix 3 gallons of juice with 1 gallon of water? Well, that one's still kind of easy. You have 3 gallons and 1 gallon, so that's 4 gallons. And so if you have 3 that's juice and 1 of water, that's 3 out of 4 gallons is juice. That would give you 75%. So we could do those in our head. But when they start changing these, the same question, just with different numbers, becomes very difficult. So here's the equations you're going to need for mixtures. All right. There's 6 variables here. We're going to say V1 is the volume of liquid number 1. C1 is the concentration of liquid number one. So this first question here, we're mixing 1 gallon of 100% apple juice. V1 would be 1 gallon and C1 would be 100%. All right. We have V2 is, let's cheat here. Oh, hell. Copy. Paste. Volume of liquid number 2. C2 is the concentration of liquid number 2. So if we're mixing a gallon of 100% apple juice with 1 gallon of water, this is our second liquid here. We get 1 gallon, so that's V2. And the concentration, well, since this is pure water and has no juice, concentration 2 here would be 0%. Water is 0% juice. Okay. And now we also have the resulting liquid. So we have two more variables here. We have V3 and C3. Okay, volume of liquid number 3. This is the resulting mixture. All right, so those are your 6 variables. So when you have questions like these mixtures, all you have to do is identify what's the first liquid, what's the second liquid. See, these two are getting mixed together, and this is what you end up with left. And here's your equation. All right, if you take the first volume and multiply it by its concentration and add that to the second volume at its concentration, you get the third volume at its concentration. So that's the big equation that allows you to do all these mixture problems very simply. Okay. So first volume, second volume, first concentration, second concentration. You're adding them together, you're mixing them, and you're getting a third volume and a third concentration. So there's one more other equation that we know, it's obvious. If you take the first volume and add it to the second volume, you get the third volume. So up here, we're mixing 1 gallon with 1 gallon. So our V3 here would be 2 gallons. Does these equations make sense to you at this point? Anybody?
It is a little confusing, but I mean, if you just follow the formula.
Yeah, this is our formula. Let's follow it. So let's do this easy one here. We're mixing 1 gallon of 100% apple juice, right? So this is V1. This is C1. We're mixing it with this. This is V2. Water means C2 is 0% because it's 0% juice. How much total liquid results? That's V3, resulting volume. And what percent is juice? That's C3. So let's plug in our numbers. We have 1 gallon, right, of water. I mean, of juice. And it's at 100%. We're mixing it with 1 gallon of water, which is 0%. And we're getting a third volume, right? And a third concentration. That's what they're asking us for. So this is our setup equation. But we know that V1 plus V2 is V3. So we know that 1 plus 1 is 2. So that's our V3 here. So we could take V3. We know it's 2 gallons. Okay. So what we need to solve for is the third concentration. So 1 times 0 is just 0. Okay. So what we have here is 100%, because 100 times 1 is 100, is 2 C sub 3. Divide both sides by 2. We have C sub 3 is 50%, which is what we expected. You have a gallon, 100% juice, a gallon of water. You end up with 2 gallons at 50% concentration. Let's check out the second one here. The second question. 3 gallons of juice with 1 gallon of water. What is our equations? V1, C1, V2, C2, V3, C3. And V1 plus V2 is V3. So what is V1? This question, what's our first volume? Anybody tell me? All right, that's our first liquid, right? How many gallons do we have? 3, right?
Yes.
So we have 3 gallons is volume 1. What's its concentration? Well, they just say juice, right? 3 gallons of juice. I'm going to assume that that means it's 100% juice, right? Percentage. So juice means 100%. They didn't give me a concentration. So I'm assuming that when they say 3 gallons of juice, they mean it's 100% juice. We're mixing that with 1 gallon of water. So that's our second liquid. We're mixing it 1 gallon of water, and water is 0% juice. All right, so we know V1 plus V2 is 3 plus 1. It gives us 4 gallons, right? We're mixing 3 gallons with 1 gallon, so we got 4 gallons. That's our V3, our third liquid, the resulting liquid. So now, since we know V1 C1 plus V2 C2 equals V3 C3, we could plug in our numbers here. V1 C1 V2 C2. So we have 3 at 100%. Then we have 1 gallon at 0%. Gives us 4 gallons at I don't know percent. So we need to solve for C3 here. 1 times 0 is 0. So over here we have 3 times 100 is 300. So let's just divide both sides by 4. So our C3 here is 300 divided by 4. And that gives us 75%, which is what you'd expect. There's 3 gallons and 1 gallon. That gives you 4 gallons. 3 out of 4 of the gallons is juice. So you got 3 pure juice and 1 that has no juice. So yeah, it's going to be a 75% concentration. Does that make sense?
Yes, sir.
All right. Yeah, all of these mixture problems, it's always going to be using these 2 equations. All right, notice there's 6 variables, right? They're always going to give you at least 4. See here, they gave us 4, but because we have 2 equations, one of them is going to give us the 5th. You know, most of these, they give you V1 and V2, so you can easily figure out V3. So then you know 5 out of 6 of these variables. Once you have 5 out of 6, you can use this to solve for that sixth one, whether that you might be solving for V2 or whatever. As long as they give you, you get 5 out of 6 of these numbers, you can solve for the last number. Okay, so it's not always going to be solving for the resulting concentration. They might give you the resulting concentration and be asking you about the concentration of one of the other two liquids. But you just plug in the numbers, you know, figure out which ones they go to, plug them in and solve. See, it's 11:30. You want to take a break?
Yes, sir.
All right, I guess 15 minutes. Is that good?
Yeah, that's good.
All right, we'll come back at 11:45. I'm gonna pause the recording. Y'all remind me to start it again, because I'll forget. Zoom recording. Y'all with me?
Yes.
So we did 19. Number 20 here. All right, we have 2 cups of water from the Great Salt Lake of 10% salinity. So 2 cups of water, that's our V1. And it has 10% salinity, so that's C1. It's 10% salt. And it's mixed with 2 cups, that's our V2, of swimming pool water of 0% salinity. So swimming pool water has 0 salt, so that's our second concentration. How many cups result? That's our V3. And what is the salinity of the mixture? That's our C3. So we have V1 here is 2 cups. C1 is 10%. V2 is 2 cups. C2 is 0%. So what's left? V3 and C3. We don't know what C3 is. V3, this down. We know that it's V1 plus V2. So that's 2 plus 2 is 4. So we know V1, V2, C1, C2, and V3. All we don't know is C3s, but we can plug this in, right? V1, V1, C1, V2, C2 equals V3, C3. So let's plug in our numbers here. V1 is 2. C1 is 10%. These percentages, you can write them like this, or you could write it as 0.1. Either way, your answer is either going to be in decimals or in percent, so you can do it either way you want. See, V2 is 2. C2 is 0%. V3 is 4. And we don't know what C3 is. So that's our setup. This is just 0. So 10% times 2 is 20%. Is 4 C3. To get to the C3, we divide both sides by 4. So C3 is 20 divided by 4 is 5%. All right, does that make sense?
Yes.
Oh, we were supposed to estimate before we solved it. Let's see if we can estimate. 2 cups at 10%, 2 cups, 0%. So we have half of it, 4 cups total, half of it was at 10%. So let's see. If half of it was at 100%, it would be 50%, right? If 2 cups were pure salt and 2 cups were no salt, we'd have 4 cups at 50%. But the 2 cups, instead of fully salt, they're only 10%. So it makes sense that it should be reasonably small percentage because there's only 10% in half of it. All right, let's look at it. All right, if we pour 3/4 of a cup of creamer, so this is our V1, and it says that the creamer is 12% fat, so that's our C1. We're pouring that into 2.5 cups, that's our V2, of coffee. So what we're looking here from this is percentage of fat. So our coffee here, when they say coffee, that's our C2. That means that it's coffee doesn't have any fat in it. So our C2 is 0%. So how many cups result? So V3. And what is the percent fat? That's our C3. So we don't know. All right, let's try to estimate a reasonable percentage before we answer. So we have 3/4 of a cup of creamer and 2.5 cups of coffee. So it gives us what, 3¼ cups total, and 3/4 of a cup at 12%. 12% isn't very much, and 3/4 of a cup isn't very much. So I'm thinking something like small, you know, like 2 or 3% maybe. What do y'all think?
I was also thinking about 3%.
All right, let's plug in our numbers here. See, V1 is 3/4 of a cup. It's also 0.75 if we want to do it with decimals. C1 is 12%. V2 is 2.5 cups. So that would be 2.5, right? 2.5. And it's pure coffee, which has no fat in it. So C2 is 0%. V3 is V1 plus V2. So it'd be 3.25. 2.5 plus 0.75. So what is C3? Well, V1, C1, V2, C2, V3, C3. So V1 is 0.75 at 12%. Then we have a 2.5 at 0%. And this gives us 3.25 at some concentration. This one here again is just 0. Let's see, 75%, 75% of 12%. Let's see, 12 times 0.75 is 9. So this right here is 9. 3.25 C3. So to get the C3 by itself, divide both sides by 3.25. So we have 9 divided by 3.25 equals 2.769%. So yeah, we did pretty good at estimating there. It's pretty close to 3. right, any questions on this one? Just like the other two. You know, there's this, the setup is kind of, can be kind of complicated because you're trying to figure out the concentrations and it's like, well, what does that mean, a concentration? Well, we figured that out when they said 12% fat. We're focused on fat as what's concentrated. Hey, puppy dog, you okay? You okay? You just want attention, don't you? Come here. Sit on my lap. Just don't wiggle too much, all right? All right, that's 21. So we've got 22 here. So we have 20 pints of a 2% saline solution. So what's our V1 here?
$20 pints.
That's right. It's 20. And we're working in pints here, okay? So what's our C1?
2% saline solution.
C1 is 2%, and we're working with saline. That's the what means what we're focused on as far as concentrations. So we're mixing it with 15 pints of a 9% saline solution. So what's our V2?
$15.
Right, V2 is 15 pints. What's our C2?
That would be your 9% of saline.
That's right. It's all about the saline. So how many pints are in the final mixture? So that's our V3, right? What's our V3? V1 plus V2, which gives us a
35.
Yeah. All right. Here. Lay down. Lay down. That's it. You'll be okay. Okay, so what is the percent of saline in the final mixture? So that's our C3 that we don't know. So let's try to estimate this. 20 pints at 2%. Well, that's not very much at all, right? 15 pints of 9%. Let's see. So we have more 2% than we have of the 9%. It sounds like if it was all 9% instead of, right? If we had 20 pints of 9% and 15 pints of 9%, it would all be 9%, right? But since this is less than the 9%, that's going to make the saline concentration go down. So it's going to be less than 9. And it's going to be more than 2. Since there's more pints at 2% than there are pints at 9%, it's going to be closer to 2% than 9. So I'm thinking maybe like 4% or 5%. Because right in the middle, let's see, right in the middle would be 5.5%. So if it was equal pints at 2% and equal pints at 9%, it would be directly in the middle between 2 and 9. But since there's more 2% than there is 9%, it's going to be closer to 2 than 9. And right in the middle would be, let's see, there's a 7% difference. Half of that is 3.5. Right in the middle would be 5.5%, but it's closer to 2%. So I'm thinking like 4.5 maybe. So let's see, what do we get? V1, C1, V2, C2 equals V3, C3. V1 is 20 at 2%. V2 is 15 at 9%. And we get 35 at the unknown percent. We multiply these out, 20 times 2 is 40. And what's 15 times 9? 15 times 9, 135%. So all I did is multiply these, okay? So now we'll add these, 135 and 40 is 175. And now to get C3 by itself, let's divide by 35. So 175 divided by 35, 5%. Yeah, we were close. 5%. It's in between the 2% and the 9%, but it's closer to 2 than it is to 9, right? It's only 3 away from 2, but 4 away from 9. Does that make sense, y'all?
Yes, it does.
All right.
Try to get like simpler every problem we go through.
Right, it makes a little bit more sense each time, but practice helps. So let's look at 23 here. All right, we have 2 liters of 3% milk. So what's our V1?
Two liters.
That's right. V1 is 2. We're looking at liters here, right? I'll put an L here for liters. And what's the C1?
3% milk.
C1 is 3%. And it's mixed with some 1% low-fat milk. So notice here, some, that's our V2. They don't tell us how much. So our V2 is unknown. But we know its concentration, it's 1%. So if there are 7 liters of the mixture, what does that tell us? There are 7 liters of the mixture.
The V3.
V3 is 7 liters, yeah. So how many liters of 1% low-fat milk were there? So that is V2, right? That's what they were asking about. It's mixed with some 1% low-fat milk. How many liters of that are there? So let's see what we got. We don't know what C3 is. They didn't say anything about the concentration of the 7 liters. And they didn't tell us the volume of the second liquid. So what we do here is, remember, we know that B1 plus B2 is V3. See, we know that V1 is 2 liters. C1 is 3%. V2 is unknown, but C2 is 1%. C3 is unknown, but we know that volume 1 plus volume 2 equals volume 3. Okay. So they told us that volume 3 is 7 liters. So V3 is 7. Because we know volume 1 and we know volume 3, we can solve for volume 2. We plug in what we know into this equation. We have 2 plus whatever V2 is going to give us 7. So if we subtract 2 from both sides, We know that B2 is 7 minus 2 is 5. Okay. So we can change B2 here to 5. So sometimes you have to use this one, you know. Because notice they gave us 1, 2, 3, 4. They gave us 4 numbers out of our 6 variables. So we're using this one to get a 5th. Now that we have the 5th one, we can solve for our C3. Okay. So how do we get our C3 here? They don't even ask for it. All they ask for is how many liters of 1% low-fat milk were there. There's 5 liters. That's our volume 2. But let's solve and see what our concentration for the mixture is. All right, B1, C1, B2, C2, B3, C3. You know, B1 is 2 liters at 3%. B2 is 5 liters at 1%. And that gave us 7 liters at our 3rd concentration. So if we want to solve for that concentration, 3 times 2 is 6. 5 times 1 is 5. So we have 11% equals 7 C3. So C3 is 11 over 7%, which is 11 divided by 7. 1.57%. But again, this question, all they were asking about was the second volume. All right. All the other problems, they gave us volume 1, volume 2, and we used this to get volume 3. The only thing that made this one different is instead of giving us volume 1 and volume 2 to get 3, they gave us volume 1 and volume 3, and we used that to get volume 2. Does that make sense?
Yes.
Okay. This one. I'll be right back. I gotta grab a glass of water. Okay. All right, mixed practice. Let's see, there's 425 stats students at Northwest Vista. 35% plan to attend nursing school. If all the students who plan to attend nursing school are enrolled in statistics this semester, what percent of the 15,435 NBC student body plans to attend nursing school? All right, let's think about this one. We have a bunch of stats students. Some of them are attending nursing school. And if all of the students who plan to attend nursing school are enrolled in statistics, which ones are going to nursing school? So if you're in nursing school, you're enrolled in statistics, period. And 425. So some statistics students are going to be nurses, some aren't. But anyone that's going to be a nurse is in stats. And 35% of the 425 will be nurses. So what percent of the total? Well, let's see how many. If we have 425 stats students and 35% are going to nursing school, this is going to tell us how many are in nursing school, right? So 425 stat students, 35% are nurses. That gives us 148.75 nursing students. Okay. They want to know what percent of the total population that plans to attend nursing school. Well, we have 148.75 nursing students out of 15,435. So that gives us 1,435. 0.009637 or 0.9637%. So that's less than 1%, right? 15,000 students. There's only 140, say 150 roughly. 1% of 15,435 would be 154 students. So this is less than 154, 148. So yeah, it's a little bit less than 1%. So this is a two-step problem here. First, we figured out how many nursing students there were, and we just compared that to the total number of students in the school. Any questions?
No, sir.
Okay. This is a lot of words to portray a simple question, right? All right, a pre-election survey showed that 5 out of every 13 registered voters would vote in an election. At this rate, how many people would be expected to vote in a town of 5,850 registered voters? Well, we could set this up as a percentage, or we could set it up as a proportion. We've got 5 out of 13, 5 vote out of 13 registered. So how many would vote out of 5,850 registered? So that's one way to do it. Set it up as a proportion, voters to registered voters, and then solve for X. We'd multiply both sides by 5850. That goes away. We have X is registered voters go away. 5850 times 5 divided by 13 is 2,250 voters. That's one way to do it. The other way is using percentages. 5 out of 13. All right, we take 5 divided by 13. This is 0.3846 or 38.46% vote. That's the percentage that actually vote. 3 out of 5. I mean, 5 out of 13. So if that's the percentage that vote, we take the total number of registered voters and multiply it by our percentage that vote. So 5850 times 0.3846 gives us 2,249.91. And I'm not getting exactly that because I rounded the decimal, right? Right here. 5 divided by 13. This is approximately equal to this, right? It actually keeps going. 1, 5. Okay. So if I keep the whole, if I use the fraction instead of the decimal, so instead of writing this as a decimal, if I just leave that as 5/13, that is the percentage. I'll get the most precise answer, 2,250. Okay, any questions about this? You got to be careful of rounding, right? Why would we put this decimal when we could use this? Because it's the same number. This is just not as accurate as that. And so if we use the decimal, you saw that we were off by like 1/10 of a person. So use exact numbers when possible. Okay. Try one more here. To estimate the number of trout in Big Bear Lake, a sample of 48 trout were captured and tagged. Okay. After releasing them, a net captured 300 trout. 9 were tagged. Estimate the number of trout in the whole lake. So these are kind of cute here. So let's look at this. They reached in the lake, grabbed 48 and tagged them. All right. So we know that 48 out of all the fish in the lake are tagged. Does that make sense? X is the number of fish in the lake. We reached in, tagged 48 of them. So here's our proportion here. So 48 out of all of them. Then they reach in a net, they catch 300 and 9 were tagged. So 9 out of 300 are tagged. So 48 out of the total versus 9 out of 300. All right, this is a standard way to estimate populations. So now we solve for X here. We do the quick flip both sides. Okay. Now to get X by itself, we multiply by 48. So X is, let's see, 300 times 48 divided by 9. 1,600. It's a neat trick, right? You just reach in, tag some of them, and then later catch a bunch, see how many are tagged. And because of proportions, you can estimate the number of fish in the entire lake. Let's look at 27 here. Kelly takes her friends out to lunch and pays for the bill. Her friends insist on paying the tip. The bill is $38.75 and they want to leave a 15% tip. How much money will they have to leave? The bill plus the tip. You got $38.75 Multiply that by 0.15 to find out what the tip is. We have 38.75 times 0.15. This gives us $5.81. So the total, the 38.75 plus the 581 tip gives us 44.56. Let's see, we have about 15 minutes left, so I'm going to give you your exam number 3. One, solve for x. All right, let's do 2/5x equals 7. And now for number 2, let's see. $17 is what percent of 80? All right. Remember, you have access to the tutoring on the syllabus. There's a link there. Utilize that tutoring lab if you're having trouble with this stuff. And remember, practice makes perfect. You know, it just takes work, and you can get this down. This stuff is it's complicated, but it's not harder than most video games that we get good at. It's actually easier than most things we do in life. It just requires a little bit of work. All right, any questions?
No,
No.
sir.
All right, y'all are free to go. I'll be here.
Have a good day.
Have a great day, sir.
Y'all
Good day, sir.
Have a good one.
Have a good day.
bye, everybody.
I do have a little question. Do you want us to round the number that we get for number 2 on the exam?
Yeah, just round it to a couple of decimal places. I'll be able to tell what you rounded it to, you know?
Because the number I get, because I mean, it was like really quick to do. So the number I get, it doesn't have like multiple decimals, if that makes sense.
That's fine. Round it to whatever you want. You can just tell me what you rounded it to, you know?
Okay.
You get an answer, just say this is rounded to so many decimal places.
Okay, then thank you.
Absolutely.
Have a good day.
You too. Bye-bye, y'all.
Thanks.